Now here's the algorithm I was able to come up with. Knuth calls it algorithm P. Other people have discovered it before him, so it's been discovered over and over again. And the idea is you just go through the deck and make one swap for each of the index I, and what we swap it with gives an equal chance for any of the items that haven't been seen yet to occur in position I. So again, we've got our deck, and we're going through one at a time, looking at each position. And when we get to a general position I, we're going to swap I with the range from I through to the end. So we're going to pick out, for this element I, any one of these elements, and then swap them. Say we pick this one, then we would swap those two, and then we'd move on to the next position of I. So the very first element, we pick any element in the array, swap it into the first position. Then we look at the second element and pick any element from the second on, swap it into that position, and so on. And so we can see that every element in the array has an equal opportunity to appear at each position. So the qualities of these algorithms, of this algorithm that I like, is that it's so simple and clear. It just says in one statement. It makes it obvious that each location I can have any of the elements of the deck with equal probability. Now, there's one part of it, I guess, which is not the most clear, which is, are we exactly right here? Here we've got n, and here we've got n minus 1. And that should bother you a little bit. Do we have this right? In general, ranges are tricky in Python because ranges go from, if we say random range from I to n, it's not going all the way up to n, it's only going to n minus 1. And same thing here, if we say from range to n minus 1, that's actually the biggest number there is n minus 2, but there's n minus 1 of them because we include 0. So ranges are always a little bit tricky. We can have these off by 1 errors. We want to make sure that we got this right. And so let's have another quiz. And the quiz is, for that statement, for I in range n minus 1, what would happen if we replaced the n minus 1 with an n? And the options are, would that give us an index error that we've gone too far into the deck and we have the wrong index? Would it give us a value error from random range? Would it tell us you've got the wrong number in there? Would it give us no error, but the results would be unfair in that one permutation of the deck might be more common or more probable than another? Or would it give us no error and still be fair, but maybe just a little bit slower?